Question 6. An object has a constant non-zero acceleration. Which of the following displacement time graphs could represent the motion of the object? Important point given in the question is non-zero acceleration. That means the object has a specific or particular acceleration. You should remember that gradient of displacement time graph represents velocity. This gradient of displacement time graph represents velocity. In the graphs A, C, and D, we have straight lines, which suggests that gradient of each graph is constant. Therefore, the velocity of the objects which are represented by option A, C, and D are constants. Only in the graph B, there is a change in gradient. Change in gradient suggests that the object's velocity is changing, which means object is moving with an acceleration. So the option B should be the answer for question 6. Question 7. The forces acting on a helicopter are shown. The helicopter is represented by the dot. Which of the following expression gives the magnitude of the resultant force in newtons on the helicopter? We have two vertical forces and one horizontal force. We can first identify the resultant vertical force by simply taking the difference between vertical forces. So that should give us 15,000 minus 14,500, which is the resultant vertical force. And then the only horizontal force is 200 Newton. If you are trying to find out the resultant of force on the helicopter, we should find out the resultant of these two perpendicular forces. For two perpendicular forces, resultant force can be found by applying the Pythagoras theorem. So our answer should be 15,000 minus 14,500 squared plus 200 squared. But since we want to find out the resultant, we have to take the square root of this expression. So the answer for question 7 should be option D. Let's move on to question 8. A box of weight W slides down a ramp. The ramp is at an angle theta to the horizontal. A frictional force F acts on the box as shown. Which of the following is correct when the box moves at a constant speed? So if the box moves at a constant speed along the ramp, which is parallel to the ramp, forces parallel to the ramp must be equal according to Newton's first law. Since the object is moving with a constant speed, the forces must be balanced. So the weight component of the box should be equal to the frictional force which is in the opposite direction. How to find out the weight component? In this diagram, they have given us angle theta. If this angle is theta and this angle should be 90 degrees because horizontal and vertical. So the angle between the ramp and the weight would be 90 minus theta. That would give us angle between weight and the perpendicular component to the ramp to be theta. So if we resolve weight into two components, one component parallel to the ramp which is W sine theta. The other component is perpendicular to the ramp, which is W cos theta. So force F should be equal to W sine theta. So the answer should be C. Let's move on to question 9. The driver of a car applies the brakes. The frictional force between tires and the road is constant. The average power dissipated by F is 50 kilowatt. The car moves distance of 13 meters in a time of 2.3 seconds before coming to the rest. Which of the following expression gives F in newtons? So work done by the frictional force is given by force times the distance. Force times the distance. If we divide this work done by the frictional force by the time it is being applied, we get the power dissipated due to the frictional force. In this problem, they have given us the power as 50 kilowatt. So that would be 50 times 10 to the power 3, since when we convert kilowatts into watts, equals to force value we don't know. The distance is 13 meters and the time is 2.3. If we subject F the force with this from this equation, we get 50 times 10 to the power 3 times 2.3 divided by 13. So the answer should be option B. Sorry, option A. Let's move on to question 10. A toy train of mass 3m moving with a speed v, a toy truck of mass m moving with a speed of 2v in the opposite direction as shown. Train and the truck collide and move off together. Which of the following expressions gives the new speed of the train and the truck? This is a collision problem, which means we will have to apply principle of conservation of momentum. According to the principle of conservation of momentum, total momentum before the collision should be equal to total momentum after the collision. Total momentum before the collision would be 3m times v for the first trolley, which is traveling to the right hand side, plus uh, m times 2v for the second trolley, which is moving to the left side. If we actually take the same direction, if you consider the same direction, this should be written as minus, negative, and the direction would be to the right hand side. So the total momentum after the collision we can find by multiplying the total mass, which is 3m plus m, gives us 4m times the new velocity, which we don't know. I'll write new velocity as v new. We can see that mass cancels out. So the simplified answer would be 3v minus 2v over 4. 3v minus 2v over 4, which gives us v over 4. Therefore, the new velocity is given by v over 4, which is option A.